Okay, so I would like also to talk a little about the canvas. This is the canvas for uh, microelectronic 2000N, but similar canvas room has been also available in MIE 3200N. You can see in this canvas room there are a different link. Here you can look into the Emneplanen. So there is it will kind of transfer to the website where you can see the description of the Emneplanen. And you can also read about the content of the course and all the requirements that the course that are inside of this course. Then you can also see about the pensum literature. So if you click here, you can see that there are two books, one for the electronic part and one for the packet technology part. You can read them to see which is the most, which is the one that we are using, the current version edition. Then we have here, if you click here, we have the connection to the time edit, so you can see where are what is the time schedule of our course. And then here you can find the forelesning planner for packaging and also for electronic. So if you click here, you can see we have already set up the different forelesning. We have forelesning in every week except week 40. And I already divide the lecture here that we will have. There could be some slightly change along the teaching, but not in terms of topic. So the topic will still remain the same, but maybe we will be able to go faster or slower, depend on your ability to follow the course. Every week from the next one, there will be lab. And as may some of you concern, then the lab has to, I think, is an important part of this course and has to be done. We will try to propose some rules that minimize in some way the contact between all the students and minimize any risk. Although again, I think it's a good thing that you should come anyway to the lab. The rule will be soon available in Canvas, and I will let you know when this rule will be available. So the laboratory will be every week on Potirsdag, and we will have also to perform a project which is mainly laboratory oriented. For the moment, again, we still keep the same time plan that we had the other years because the university does not have any particular restriction. However, if any restriction will come out during the semester, we will then adapt the project and the lab requirements according to the new rules. But at the moment, this one is the time plan. So you will have the week 44, week 45, in which I know that you are very stressed because you're focused on the project. And if I ask you to do new lectures and if I ask you to do labs, then come to me and complain that is too much load. So for this year, I decided to leave you 2 weeks, 2 full weeks, just to work on the project. And also because due to this situation, you may not have time to use the lab as much as you want because the limit access that we have in the lab, then I think this 2 week will play a good, will be very useful for you. After the project, we will start again to finish the course program, which is MOSFET and MOSFET circuits mainly. As soon as the project finish in week 45, so we have the deadline for the final report that has to be prepared for this project on Monday 12 at clock at 12 of the week 46. After that, you have to prepare a PPT and a representation which kind of summarize your work about the project. And the oral presentation will be Tirsdag. I think, sorry, Tirsdag will be the lab. So in this week 46 will be lab 9. The oral presentation will be Torsdag eller fredag of week 46. This is because anyway, we have some also constraint, bureaucratic constraint, me and Vo, because we have to send out all the cushion for all the lab and all the obliques. I think within week 46, so we need to have your evaluation of your project within this week. Yeah, so there is time, there will be time to look into the topics of the course, but just to give you a brief summary, we will go through digital electronics, electric circuit theory. These two parts, they are those ones that you have already studied, at least the basic concept have been already introduced in digital technique and elektrische Kretse, FAG. So I definitely suggest you to look into these two courses and try to review the concept that you've learned, especially for Elektrische Kretzer. For the we are going to use all the concepts that you have learned in this course, Elektrische Kretzer. We will use also a few concepts about the digital technique. So you have to remember what is a logic gate, the Boolean formulas, Boolean algebra, and so on. So please review these concepts. I will also indicate to you what are the book where you can find these topics. So I will, in Canvas, I already wrote in which book you can look about these topics. Yeah. Then I will introduce electronic systems to you, and I will explain a little of signal theory, although you will have signal behandling next semester, but we need some of those concepts now. We will talk about Laplace transform, Fourier transform, Fourier series, because they are very important for explaining some very, very, very important concepts about signals. In particular, you have seen now that signals are represented in time. So you can just draw a certain waveforms like a sinusoidal signal, triangular wave, or square wave. But they are all dependent on time, right? However, there is another way to represent signal, which is in terms of frequency. And in that case, to understand what's going on there, you need to know Fourier series, Fourier transform, and Laplace transform. It's very important, therefore, that you understand what is going on in the course, which is parallel to this one, which is called, which is Mate 2. Because talking with Neon, he also ensured me that Laplace transform, Fourier series, and Fourier transform, they are the first topics that he's going to explain in his course. So this one should already give you a little times to master these concepts in some way. So please do not neglect or do not underestimate these topics, because definitely we are going to use them for all the course, and so this is important that you acquire this knowledge very well. We are going also to study concepts related to operational Verstärker, which are called op-amp, operational amplifier, and we are going to use these kind of components in different circuits to realize amplifier, comparators, signal generator, and so on. In week 40, we don't have lecture. I usually leave week 3 for you to review theory we have studied during the week 33 to week 39. In week 41, we are going to discuss about a little the theory behind the PCB design, because you are going for the project to realize a PCB and also to design it, and you need a little a few concepts about this design. We're going also to talk about parasitics and noise, which are secondary phenomena that happen in electronic circuits. We're going to talk about semiconductor theory, which require physics concepts. So like electric field, magnetic field, something that you should probably know from physics 1. PN junction also is related to the semiconductor theory. Then we have circuits with diodes, which is another semiconductor components, which we will study in detail. And finally, we are going to study how to design power supply, how to design circuit with MOSFETs, which are a particular type of transistor. Yes, so this is mainly the teach plan for the electronic DLN. So if you click home there, you are going to this, which is the main homepage or EMSID for electronic DLN. You can also access to that page by clicking here, where it's written more information on electronic DLN fines har. You can click in reference book again, as I said before. Here there are some suggested book that you can read to get the information that you lack regarding the digital electronic concepts. So it's this one here that I assume is the same book that Jorgen used for digital technique. And for getting more information about Fourier series and transform, you can look about these other two books. They are very good, made by very good researchers and scientists, engineers that have worked in this field for a long time. Suggested books for reviewing the Laplace transform are this one here. In particular, this one is talking about how to apply the Laplace transform in electronic circuits. So if you feel that the explanation or the material regarding the Laplace transform for electronic circuit is not the best for you to understand this concept, then you can look also this kind of book and you can read about the same concept, but maybe from another point of view. So from the point of view of this Riddle, James Nelson, Susan Riddle. So you may like it more, how this explained there. We have also forelesning notater and forelesning notater 2019. For the 2020 forelesning notater, I don't have uploaded anything for the moment. I will upload soon the video and the PDF for this for listening. So you will have always the video and the PDF available. I hope this one will be a very kind of useful things for you. I have been told from the previous students that having a video is definitely something that can help the students. Yeah. I also try to make the PDF of the presentation I had quite with a lot of notes on it. So in this way, I hope I can provide you all the information on the PPT. However, it's also important that to understand that all the information that you will have to learn from this course, they are not all 100% reported in the PPT. So I try to fit most of the information, maybe let's say 96% of the information is there, but there is still a few things that you may want to look into the book or you want to maybe ask to me. Or in any case, I try to explain it during the course. Usually this video here that I upload here is the video which contains most of the information regarding the forelesning that we have in class. I think in this video that I upload here, again, are not video taken in real time because we have so many concepts to look into, and sometimes we lose time because I'm coming late, or we have the break, or something else. So I think by using this video here, I can try to take advantage of this kind of like little gap of time that we lose, uh, which in the end it is just 10-15 minutes. But in 10-15 minutes, I can provide you a lot of information. So I think is it's kind of good to do it this video that are uploaded not in real time. So more information for you, and uh, a better understanding will be provided during the video. Uh, so for the forelesning Notate 2018, there are already notes available, so you can go through them to understand better what will be the topics of this course. There will be a little changing about these notes, and which are practically the slide I show in class. Again, from last year, I started to do the uh, presentation, let's say, or I start to prepare some presentation. However, I usually do not use them in class because I try to go through, explain on the whiteboard. However, the students told me that they would like also to have some notes, and then I prepare also this kind of PDF PPT. But this year, of course, this due to this COVID-related situation, I think all of these notes will come in handy or come useful. So then the notes that I will use this year will be practically very similar to this one that has been used last have been provided last year, but with a few changing. Some they will be simplified, some they will be a little more with more information. Uh, but yes, so exercises. So we have 1 hour of undervisning every week. In this hour, I try to solve exercises, but I know that this is sometimes not enough for you to actually practice on this, on the analysis and design on circuits. So I decided to prepare video and PDF where I actually discuss and solve a few exercises. In particular, the exercise I place here, they are the one that will be used for you. You will use for preparing yourself for the Obgave, okay, for the oblique. This means that, as I will say better later, the oblique will contain some exercise which are similar to the one that you will find here in the preparation to the oblique X. So I definitely suggest to go through this exercise. I solved them, so I put also the how to solve them and also an explanation on why they are solved in that way. I hope that in this way you have another further support for understanding how to analyze and design circuit. But then remember that you also not only memorize how to solve circuit. This is not a course where you memorize things, but you have to uh, understand the reason why I solve the circuit in the specific way. And remember one thing, which is very important, is that there is no only one solution for designing and analyzing electric circuit. So remember that the solution that I provide here is just a possible way to solve the problem. Typically is the simplest, but again, you might find also another way which can be more complicated, but is more close to your style or to the concept that you've learned. That's still fine. However, again, I definitely suggest you to learn and to understand the method that I explained, because, as I said, usually is the simplest or the shortest in time, and therefore is the best probably method that you can apply for solving the exercises. To do an example, to make an example, in the previous course of elektrische Kretze, you have used the complex number to solve electric circuit. In my opinion, it's much easier to use the Laplace transform, and I will show you how to do it. With the Laplace transform, you can solve the circuit quite fast. If you use the complex number, it will be a little longer. And sometimes you put also some error of calculation on error in your formulas due to the fact that you have this imaginary part that is increasing the size of the formula. So please try to understand the method explained in this exercise. Oh yeah, I forgot one thing is that not here, but in the exercise we have 6 obliques. I prepare also a 7th, but it's not mandatory. You can decide to do it or not, depend on the time that you have available and if you wish to do it. So 6 oblique are mandatory, so you need to have a quotient for this quotient oblique for this exercises. But I suggest you also to do the 7th because it prepare you for the exam. Yeah. Software. So we're going to use many software in this course. Healthy Spice is IEDA, MATLAB, Healthy Spice also I will show you a little better later for circuit simulation, is IEDA for design the PCB, MATLAB again as a software for generating scientific plots. You can find here the link to download this software. I suggest to download this software before we have the labs. As you can see here, we have some tutorial I will upload soon. The LT Spice we will use in lab 2, as IEDA in lab 3. MATLAB, you will use it for the project. So I definitely suggest to learn LT Spice as soon as you can. Also is IEDA, at least install it, sorry. Just install the software before the lab, so you don't lose time then when you go in the lab to install the software. Here I skip on purpose the project because I still have to fill the precise description of the project that we will have. But again, it's something that the project aims for the realization of a electronic circuit. I will provide you later in my slide a few information about it. But again, it's still not. I'm not still decided what kind of project you are going to do specifically, but again, I will provide you more information later on. Labs, you have 9 labs where 8 are mandatory. The last one is not. There are many labs. You will find here the lab description, the PDF, Word, and also video, which explain what you have to do in the lab. Hopefully this one will be sufficient for you to understand the task that you have to do there. Please, and a very important thing is that read the lab before you go to the lab, so the day before, so you know more or less what you're going to do. And you also know what are the theoretical concepts that you need to know for doing the lab. If you know already the theoretical concepts before the lab start, then you will not lose time in the lab, okay? So you will kind of like have much more time to spend for focusing on the specific task and the practical task of the lab. So please just read the text, go through the lab text before the lab, and read about the theoretical information at the very beginning of the lab text. Last things is videos. Maybe I will put here some videos that can also help you to understand better and understand better some concepts in this course here. Okay, so this is the canvas. I hope I provide all the information here. Again, the project will be soon updated, and I will also update all the links soon. But anyway, I will keep you updated during the lectures, and or maybe I will provide some communication con so here. Yes, so I will proceed by now showing a little presentation about my part, which cover most of what I already say, but maybe with some picture that are always fancy to see, to understand better what's going on.